Okay, more problems from section 5.2. And we're actually going to start with number 27. And we want to evaluate this integral using areas. This was the integral from a to 2a of x dx. So y equals x would be the line I'm going to graph. A is going to be greater than 0, pardon me. So this is what we've got, and we're going to try to take the area. So since a is greater than 0, 2a will be to the right of a. So I put a and 2a on my x-axis. This is my line y equals x, which is just that diagonal line. And if this is a, the coordinate here is a. If this is 2a, the coordinate here is 2a because y equals x. So the x and y coordinates are the same. So I want to evaluate this area of this integral, and that's going to actually be the area from a to 2a under x, y equals x. Okay. So if we look here, we have a trapezoid. This would be the height. 2a minus 1a is just 1a. And these are the two bases, a and 2a. So I just put this in the trapezoid formula. Area equals 1/2 height times base 1 plus base 2. Area equals 1/2 a times 2a plus a. That's 1/2 a times 3a, which is just 3/2 a times a squared. So that's the value of the integral. Number 29 were the train problems. Find the distance traveled by a train moving at a constant velocity. And we want to describe it as an integral and then evaluate it. That's going 87 miles per hour from 8 to 11. So we could just write this as the integral 8 to 11 of 87 dt. Now remember, this is a constant, so I can use that constant rule, which I think was theorem 2. That's just going to be the constant times the difference of the limits of integration. So 11 minus 8, or this would be b minus ab, this would be b minus a, this would be c. So just put in that formula. And we have 87 times 3. And 87 times 3 is 261, and that was miles. Okay. And then on number 31, find the calories burned by a walker burning 300 calories per hour. That's constant between 6 and 7:30 p.m. So again, that would be the integral from 6 to 7.5, which would be an hour and a half, times 300 per hour. So that's a constant. So this would be your C, and this would be your B minus A. I think that's how they stated theorem 2. And then 7.5 minus 6 is 1.5 times 300 is 450. So you had 450 calories. So I think that's all they wanted in 31. Okay, let's take a look at some more of these. And I kind of wrote the solution, then I decided maybe I better write the problem down first. So this is the integral from 0 to 5. This is number 33, so it's in your book. The integral from 0 to 5 of x over x squared plus 4 dx. And they wanted you to work this out on your calculator. So this is the way it would set up, and I'll just put it in. And we're going to use Math 9 on this. So I show you the calculator here. And you'll start by hitting Math 9. Math 9. Oops, got to turn it on. Okay, Math 9. And you have that f and I and t. And then we're going to put the function in first. So that's going to be x divided by, so it'd be x divided by, then I'm going to have a binomial in the denominator, so I have to put a parentheses, and that's going to be x squared. Plus 4, parentheses, comma, and then it's going to be with respect to x, and then comma, and then my two limits, which would be 0 and 5, 0, comma 5, parentheses, and then enter. And then you get 0.9905, and I think that's correct. So I would put 0.9905. So that's all you have to do. Hope that makes sense to you guys. It's pretty easy, just using Math 9. And the next one, number 35, was this integral from negative 2 to 2 of 4 minus x squared dx. So we're going to end up having it look something like this. This is another way we could do this, though, is we could call this y. We could use var y vars and call this y1. And that's what I did just for the variation. So what I did was in y1, I put, let's get this out of the way. I put 4 minus x squared there. That was your function. So sometimes we'll have it in this form anyway. So, and then we can just go back. So what you would do is you go to the home screen, second, quit. And then we would do math 9 again, math 9. But then rather than having to type in the function, and sometimes this works for real long functions. So if you have them in there, it saves you a little bit of retyping. So we're just going to put vars, y vars, enter, enter, and that's going to be my function. So that was the 4 minus x squared. And then comma, x, comma, and then that was going to be negative, so I used the little negative, negative 2, comma 2, parentheses, enter. And you get 10.66666 like that. So those sixes keep going. Okay? So that's another way of doing it. So if you do use the var y vars, you could just put y1 there. And sometimes that'll work a little bit better. Okay? Especially if you'll have a long function in there and you're going to have to take the antiderivative of it anyway. Okay? Hope that helps.